Yes, yes.
Yes. Okay, so it's second last day of this 7 days FDP. Today I'm covering correlation and regression, right? So as a convention, I'll share my screen. I'll discuss the conceptual aspect of both the tests, and then we will see how we can perform them using the SPSS, right? So give me a second. I'm just sharing my screen. Okay, I think have shared my screen. Is it visible? I'm showing you the slides.
Yes, ma'am.
Yes, thank you. Okay, so the agenda which I'm going to cover today in this session are correlation, types of correlation, assumptions of correlation. Then we will see how we can perform correlation using SPSS, regression, its assumptions and performance using SPSS. So these were the agendas of this session, starting with the first concept, which is correlation. So before I say something, may I ask anyone who can tell me what do you understand by correlation?
It is a relation between two variables. When one variable increases or decreases, then other variable may increase or decreases. Then they are said to be correlated.
Yes, good. Thank you so much, sir. Anyone else? Yes. Someone else will say?
Yes, ma'am. Am I audible?
Yes, yes.
So yeah, so correlation like is a statistical tool which tells us the association or relation between two variables without telling us the causation between them, and like it typically like basically shows us the relation that with the change in one variable there is a subsequent positive or negative change in the other variable.
Very good. Thank you so much, sir. So I think you people are already knowing the concept of correlation. So when I say correlation, it is quite clear that correlation itself is indicating relationship. Co means between, right? So we are looking for the relationship between the variables when we are talking about correlation. According to slide which you can read here, I am saying this thing that in correlation, in the statistics, correlation is like a counter stone. It's a very important statistical tool. Why I'm saying this reason is very simple, that when we are performing the advanced statistics, in that case, generally we need to know this thing whether the variables are having any relationship or not. Because some of the tests which are requiring to perform, generally looking for that variable should be related to each other. So that is why correlation becomes a, what I just can say, building block or very basic statistical tool in statistics, right? So as it is written, it is a very important tool to measure or to find the variable or the relationship or the relatedness between the variables. That is, up to what extent two variables are related to each other, right? So the extent of relationship we can understand or can measure using the correlation. Now, when I'm saying extent of the relationship between the two variables, the meaning is very simple. I'm saying that the degree of relationship or the strength of relationship which we are measuring using the correlation. That means we are saying what is the degree of relationship between the two variables that we can measure using the correlation, or we can say what is the strength of the relationship. That is whether the variables are strongly related to each other, whether the variables are moderately or weakly correlated to each other. This type of study we can do using the correlation. And when we talk about correlation, generally correlation is said it is helping us to understand the linear relationship between the two variables. Linear relationship meaning is what? That means when you are increasing one variable by x unit, other variable will also increase or decrease by the x unit. So that way, the proportion change will be same in the two variables. So we can say we are studying the linear relationship using the correlation, right? I think you can see the example which I tried to quote here. which is saying the more efforts we are putting in this study, the more we will learn, right? So this way you can say it is a kind of positive correlation between the two variables. So here you can see in the next slide, which is focusing on the types of correlation. In the slide, I have only mentioned two types of correlation, but usually in statistics there is so many variety, or we can say variety of correlation available. For example, it's simple correlation, partial correlation, multiple correlation, linear correlation, non-linear correlation. So apart from these two, there are varieties available in statistics. Simple correlation meaning is what? We can say when we are studying only two variables for the relationship. It is known as simple correlation. Multiple correlation meaning is what? When you are studying more than two variables. It is known as multiple correlation. Partial correlation is what? When you are studying a few variables by keeping other variables constant. It is known as partial correlation. Next is the linear correlation. So I think I just said linear correlation is what? It is helping you to understand the proportion change. So when the proportion of change is same in the two variables, that way we can say it is a linear correlation. Whereas non-linear correlation is what? When the proportion of change is not same, it is known as non-linear correlation, right? Now comes the two important correlations, which are the positive and the negative correlation. So positive correlation meaning is what? When you are saying that you are increasing one variable, other variable is increasing. You are decreasing one variable, other variable is decreasing. That means the proportion of or the direction of change is same. This is known as positive correlation. Looking at the graph also, you can see if you are plotting a graph of the two series and if the points are scattered like this, so we can say that we can understand this is the upward trend. That means we can say two variables are positively related to each other. One variable is increasing, so other is also increasing. Next one is the negative correlation. That means when the direction of change is opposite. If you are increasing first variable, other variable is decreasing, or if you are decreasing first variable, other variable is increasing. So when the direction of change is opposite, it is known as negative correlation. So the graph is also indicating you the downward kind of line you are getting when you are plotting the data or series on the plot. So this is a scatter plot, which is indicating that it is a kind of negative correlation. Also, if you are plotting your data on the graph, if you are unable to see or find any kind of what I can say, the trend or something, that way you can say, or shape, I can say, that way you can say it is a no correlation. That means the value of correlation will be 0 here, right? So this way, these are the negative and positive correlation. So again, I can repeat, when the change or the direction of change is same, increasing, decreasing, it's a positive. But other way around, if you are increasing one, other is decreasing, and vice versa, it is known as negative correlation. Two examples I have quoted in this slide: number of hours of study done by the students and the marks. So maybe this can impact, or maybe we can say if more hours will be given to the study, maybe it can improve the marks, right? Then demand and price, I think it is a very famous economic rule. We know this thing: when price increases, demand decreases, and opposite to this. So it is a negative correlation. Now, how to measure correlation, right? So after understanding the concept of correlation, we need to understand this thing, that how we can measure it. So there is a very famous term known as coefficient of correlation, right? This coefficient of correlation can help you to find the strength of the relationship between the variables. Up to what extent, up to or what limit two variables are related to each other. This is we can understand using the value of coefficient of correlation. So the term coefficient is what? It is generally whenever means and anywhere whenever we are hearing this term coefficient. So coefficient meaning is what? Generally it is a ratio kind of similar quantity, right? So that is why when we talk about correlation, there is no unit of correlation. Correlation is unit-free kind of measurement, right? So generally it is in the percent term, right? So that is why we can say coefficient of correlation is unit free. That means if you are having two variables, one variable is having a different unit, other variable is having the other different unit. In that way, you can, when you are going for calculating the coefficient of correlation using the formula, it is nullifying the units. So that is why coefficient of correlation is always unit free kind of measurement. Here in the table, you can see the interpretation of R is given. So I think everyone knows this thing, that the value of R lies in between -1 to +1. Minimum value of R can be -1 and maximum it can be +1, because it is a percent value. So it cannot be above 1 or below 1, right? Sorry, it can be below 1, but it cannot be above 1. So the range of R will be ±1. So when R comes as 0, as I just said, it is known as no correlation. R, when varying or coming in between 0 to 0.3, you can call it as a low correlation or weak correlation. Between 0.3 to 0.5 is known as moderate or average correlation. 0.5 to 0.7 is above average, and 0.7 to 0.9 is known as high or strong correlation. Lastly, when the value of R is greater than 0.9, this type of thing is known as multi-collinearity. And I think you can recall the Day-2 session. In that session, I told this thing, that when we are talking about the reliability concept, right? So I told you, between the two variables, if you're getting the value of correlation as 0.9 or above, it is an indication that two variables are almost identical. Very much similarities there in the two items or in the two variables, right? And this problem is known as, in statistics, this is known as multi-collinearity, right? So I think till here I'm clear to everyone.
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah.
Yes, ma'am. Yes.
Yes. Thank you, sir. Moving to the next. Now, talking about the type of correlation. Type of correlation is depending upon the type of variables. In SPSS, there are three types of correlation available, right? If you are having two continuous variable, means if your X and Y variable you are having and both are continuous, that is numeric variable, you will go for Karl-Pearson's coefficient of correlation. If both the variables are ordinal, you will go for Spearman's Wren correlation, or tetrachronic test is also available for applying on the two ordinal scale variable for finding the relationship. If you are having two nominal scale variable, you will go for the coefficient of phi or the lambda. Apart from that, one more test you can mention here, that is the Kendall-Stowe. In SPSS, for the nominal scale variable, we are having Kendall-Stowe test, right? So that is why I have read the table diagonally, because these are the combinations which are available in the SPSS, that is continuous, ordinal, nominal and nominal, right? So you can also see the source I have cited here, from where I have taken this particular concept. Coming to the assumptions part. Talking about the assumptions of correlation, this says the first one is both IV and DV should be quantitative. That means these should be the numeric variables. It should be measured on either the interval scale or on the ratio scale. I am talking all the assumptions in terms of the linear correlation and in terms of the Karl-Pearson's coefficient of correlation method, right? Second one is linearity, that is X and Y should be linearly related. There should be no curvy linear relationship between the variables. Next one is the absence of outliers. Usually, I think till now we have seen how to check the outliers, and I think now everyone knows whenever we are talking about the outliers, we are mostly concerned about the dependent variable, right? But in correlation, generally, correlation is not treating any variable as dependent and independent. It is only taking two variables, right? Although in the assumption, first line I have written, we need to have IV and DV, but correlation is not differentiating between your variables. It is only requiring two numeric variables. But if we want to go for some other statistical test performance on the data, so we need to have clarity that which variable we are taking as a dependent and which variable we are taking as a independent. So whatever you are assuming, so for that variable, you need to check whether there are any significant outliers present in the variable or not. Similarly, normality concept will also be applicable on the variable which you will further take as a dependent variable, right? Minimum number of observations are requiring around 30 to perform correlation. It is generally suggested that you need to have around 30 pairs of observations to perform correlation. So I hope assumptions are clear. Fine. Shall I proceed?
Ma'am, can you please show the previous slide in the assumptions?
Fine.
Yes, ma'am.
Now moving and talking about the other importance of the correlation. As I think one of sir just said when I was asking you people what is correlation or what you people are understanding by the term correlation, you said correlation is not a causation or something one of you have said, right? It is generally misunderstood as causation. Causation meaning is the cause and effect relationship. So as I just said, correlation is not differentiating between the two variables, which variable is dependent, which variable is independent variable. So it is quite obvious. It has nothing to do with the causation, because in the causation type of relationship, you have to be very clear which variable is causing change in the other variable. Means which variable is cause variable, which variable is the effect variable. That is, the dependent and independent variable should be very clear to the researcher in case of other tests. But correlation is not distinguishing between these two kind of variables, that which is dependent or which is independent. That means correlation is not at all telling you about the causation kind of concept. It is not anyway conveying us that this is your this variable is making cause or this variable is making change in the other variable. So which is the cause, which is the effect, that kind of differentiation it cannot be done by correlation. We being a researcher, as we are having our brains, we are using our mind. So we can distinguish between these two things. We can easily say this variable is maybe impacting this variable, right? You means looking around us, or maybe with the help of observation and experiences, we can say this thing. But correlation cannot distinguish these kind of things, right? So that is why we can say correlation is not a causation. Correlation is only a correlation, which is only telling you up to what extent two variables are related to each other. Now, in statistics, there are various formulae available to get the value of R, as coefficient of correlation is denoted by small r. So you can see, I tried to show you these are the varieties of formulae available, which is giving us the value of R. I think this is, I'll skip manual calculations. Yes, the steps also, I think we do not need to talk about. So this is about the correlation concept. I hope till here I am clear. Shall we proceed and perform now correlation?
Yes, ma'am.
Okay. So I think I have already provided you the sheet named as correlation in the WhatsApp group, expecting you people to open it. Just a minute. My screen is visible or not? That correlation sheet, the SPSS sheet is visible.
Yes, ma'am.
Fine. Once you have opened, please tell me so that we can proceed.
Advertisement sheet, ma'am.
Sorry?
Advertisement sheet we have to open.
No, correlation.
Okay.
We are performing correlation first. Open.
Just a moment, ma'am.
Yeah. Once you people are ready, please tell me. Then I'll proceed. Shall I proceed?
Yes, ma'am.
Fine.
Yes, madam.
Okay. So
Yes,
you
ma'am.
can
Yes.
see, yes. So you can see we are having two variables available named as reading time and the TV watch time, right? Variable view, I think we do not need to do anything. All set in the variable view. Okay. So according to the assumptions, we need to have two numeric variables. We are having that, right? We are having around 30 observations. Let me check. Yes, we are having 30 pairs of observations. Now, for checking the normality assumption and the outliers assumption, I need to priorly decide which variable further I will treat as a dependent variable. So according to you, which variable I should take as a dependent variable here?
TV watching time.
TV watching time is the dependent variable. Okay. Okay, it is fine. Everyone.
Yes, ma'am.
Yes, ma'am.
According to don't you think I should take reading time as a dependent variable?
Correct, ma'am. Yes, ma'am.
Yes.
Yes,
Means
ma'am.
you can see some yeah, you can understand this thing because I think this is a very good example I have picked, and I think first time I am discussing this example in this these kind of FDPs. Before that, this I have not discussed this example. So you can see the good thing about this example is that we can go take any variable as dependent here, but logically, if you will think that here reading time should be the dependent variable, because from the student's point of view, if we will think, so it is quite obvious most of the time students are spending their time on watching the TVs and other kind of things, right? So they are generally, then they are means they are managing their study while doing all these kind of things, right? So maybe according to me, the reading time should be the dependent variable. So as you said, should I take reading time or should I take a TV watch time?
Reading time.
Reading time, fine. Okay, so if reading time is my dependent variable, that means I need to check everything for this variable. So go to the analyze. I think till now everyone is now in the practice that how to check it. Go to the explore and then pick the reading time and shift it into the dependent list box. Till here, no problem, I hope. Done. Shall I proceed?
Yes.
Then clicking on the plots and selecting the two checkboxes, histogram and normality plots with tests. Done. Shall I click on continue?
Yes.
Now click on OK. So we are getting the output. Here the reading time is the variable. Total observations for this variable are 30. No missing value. Total is 30. Coming down and looking at the descriptive statistics. So mean, I think in case of normal distribution, I don't remember I told you this thing or not. One of the characteristics of normal distribution is the mean, median, and mode should be equal, right? So you can compare your mean and median here. Not a much difference you are finding here, but it's still there is a difference of 0.2, right? Coming down, looking at the skewness. Skewness is minus 1.46, which is very close to 0, but still it is a negative kind of value. Kurtosis is again minus 0.823, which is less than 3. Now, means it is little bit tougher for me to conclude anything when I'm looking at the kurtosis value, but skewness is fine. Coming to the normality tests, there you can find under the Shapiro-Wilks test, if I come, you can see the significant values coming as 0.623. So anyone who can help me, now what I need to do? If significant value is 0.623,
We'll hold the null hypothesis.
we will
Accept.
hold the null hypothesis.
Hold the null hypothesis.
Very good. So what we will conclude, ma'am?
That it is the data is normally distributed.
Very correct. Very good. Very impressive. Thank you so much. So we will say that Seproville's test null hypothesis need to be held by us as the significant value is greater than 0.05. So we'll conclude that the variable is normally distributed. Coming down, looking at the histogram, it is little bit tougher to conclude using the histogram because number of observations are only 30, but still, if you wish, you can keep the distribution curve on this, close this, and close the editor also. So that way you can see little bit tricky this histogram we can find to conclude anything using the histogram, right? So maybe, as I said, up to you which method you are opting. Coming down, looking at the QQ plot, some departures we can observe here from the fitted line or from the solid line, right? So again, it is little tough to comment on the normality using the QQ plot. Going down, fine, and looking at the box plot. So beyond the whiskers, whether it is the upper or lower, beyond the whiskers, we are not getting any circle or any asterisk. So that means we can say there is no outlier available in the reading time variable. And also the normality is maintained by the variable as the significant value of the test, Shapiro test, is greater than 0.05. I hope it is clear.
Yes, ma'am.
Yes, ma'am.
Okay, I think this is also I'm trying for the first time. I'll try first and then I'll tell you. Give me a second only. Okay. So I think one more assumption was there, which was related to the normality, right? So for that, normality, not linearity. So what you need to do, click on the graphs. You can find chart builder, click here. Then you are getting this kind of window. Everyone, I hope you found it.
Can you please repeat?
Okay, go to the graphs, select chart builder, click on this. Done. Done.
Yes, ma'am.
Here, for checking the linearity, you need to draw the scatter plot. So at the bottom, where you can see choose from, you can select the scatter oblique dot. Then all the related combinations, all the possibility of the graphs which comes under this are listed at the right side. I'll click the first one, which is the very basic one. So you can double click on this or you can drag and drop this into the preview area like this. Then
Okay.
so shall I proceed?
Yes.
So we have just discussed reading time we are taking as a dependent variable. That means this will be our y variable. So x variable will be the watch time, TV watch times. You can shift it into the or onto the x-axis. Similarly, reading time, pick and drop it on the y-axis. Then you can see properly both the variables are shifted. Then
Yes.
then click on OK. So once you are clicking on OK, I hope you can see the scatter plot. Then done. Friends, yes or no?
Yes, ma'am.
Okay, so shall I proceed to the next step?
Yes, ma'am.
Fine. So after this, you need to double click on the chart area of a scatter plot. Then Done? Done?
Yes, ma'am.
And then at the bottom ribbon, where we have selected the distribution curve previously, you can find there is a add fit line at total is available. Right? From the left side, fifth option. Or I think it is a middle option. From both the sides, it is at the fifth position. Done? At least say yes or no, I'm not getting, are you getting or not? Because first time we are doing this. Done?
Yes,
So
yes.
after this, once you have selected this, a window will open of the properties. You can close it and you can close that editor also. You would be able to see the fitted line on your scatter plot. Done?
Yes,
Yes.
madam.
Now you can see this is indicating you a linear relationship as the trend is going downward, right?
Yes.
Fine. So means we have checked all the assumptions. Now we are ready to perform correlation. So for the purpose, go to the analyze, correlate, and bivariate. Once you have found this, tell me so that I can proceed. Yes. Everyone?
Yes, ma'am.
Okay. Now click on this, a window will appear. Select your variables, shift them into the variables box. Done?
Yes, ma'am.
Now, in the options, you can find if you want to get the mean and standard deviation, you can select this. If you want to get the cross product deviations and covariances, you can select. But I think these are not our requirement. So nothing you need to do here. Come down and check. First section is telling you correlation coefficients. So there are three: Pearson, Kendall-Stout, and Spearman. Right? So I think I told you all three. By default, Pearson is selected, means according to SPSS, we are considering two numeric variable. But if we want to change, so we can deselect this and we can select the other one. So according to your variable, you can select the type of correlation which you want to perform. Next section is regarding the test of significance. So it is by default giving you the significant value for the two-tailed test. If you wish to get the one-tailed test significant value, you can click on this. But I think we'll go with the two-tailed test. Then lastly, it is telling you flag significant correlations. If your correlation is coming significant, it will be flagged. Flagged meaning is there will be some asterisk sign. So that way you can see that your correlation is significant or not. So that means if in a, I can say concise way, if I will say this thing, except shifting your variable from the left side to the right side, nothing you need to do to get the output. You can directly click on OK. Done? Getting everyone?
Yes, ma'am.
Now
Yes,
you can see, yes. Now you can see we are having the correlation between reading time and reading time, which is coming as 1. So it is obvious and very, very, what I can say, logical. When we will find the relationship between the same variable, the correlation will come 1. But between reading time and TV watch time, you can find the correlation is coming as minus 0.617. And you can see there are two asterisks also. That means your correlation is significant at 0.01. That is at the 1% level, the correlation is significant. And you can also check the significant value, which is 0.000, means less than 0.05. Or maybe if it is less than 0.01, so it is quite obvious it will be less than 0.05 also. So that way we can say there is a significant relationship between the reading time and TV watch time. And if we will look at the value of correlation, we can say it is minus 0.617. It is a negative moderate correlation between the two variables, right?
Yes.
I hope yes. So friends, this way, this was the correlation. Now we are moving to the discussion of the regression concept, right? So let me show you my slides again. Okay, I hope slides are visible.
Yes, ma'am.
Okay, so shall I continue?
Yes, ma'am.
Yes, ma'am.
So now, after understanding the concept of correlation, we are coming to the regression. So regression is a step ahead, or I can say correlation is a base for regression, or correlation is a prerequisite for the regression, right? Because regression is a cause and effect relationship. It is helping you to understand which variable is making cause or which variable is causing to the effect in the other variable. So if one variable is impacting or affecting the other variable, it is quite obvious there will be certain relationship, right? So that relationship, priorly we are ascertaining up to what extent two variables are related, and then using the regression, we are finding the cause and effect relationship. So in a nutshell, I can say regression is the statistical test which can help us to understand causation, that is cause and effect relationship. Regression is a tool which can help you to understand the prediction of the dependent variable using the independent variable or independent variables. Regression is a tool which can help us to model our variables. And lastly, regression is a test or tool which can help us to understand algebraic relationship between the two variables. In the case of correlation, I already told you it is only expressing you the relationship in the percent form. But to get the magnitude of the relationship, we can look at the regression. Regression can quantify the relationship between the two variables, right? So I hope I'm clear till this point.
Yes, ma'am.
Am I clear?
Yes, ma'am.
Yes.
Ma'am, what do you mean? Ma'am, what do you mean by quantifying the regression value?
Quantifying meaning is, as I said, we can go for the modeling. So we can model two variables using a equation, right? So in equation, we are having the values of the coefficients. We will be having the values of the constant value. We can put the values of the input independent variable, and we can forecast the value of the dependent variable. That means we are quantifying the relationship. That if I'm changing this variable by these units, what is the change in the other variable? So we can get that unit change in the other variable.
So this SPSS modeling will help me in generating that equation.
No software is doing that. It is giving you the coefficient values. You need to make your own equation. So we will do that after getting the figures.
Okay, got you.
Okay. So we can say this thing, that regression is a tool which can help us to understand the cause and effect relationship. Also here in the FDP, I am talking about the linear regression. Linear regression is because there are almost 60-70 types of regressions. There are so many regressions when we are going in the time series also, including the time series also. So variety is more in the regression, but at least you need to understand, have the understanding of the basics of the regression, right? So here I'll talk about the linear regression in this particular session, right? So when I talk about regression, regression is cause and effect. That means we are treating variables as dependent and independent variables. So we want to see if I'm changing a variable by particular units, what change is occurring in the other variable, that is in the dependent variable. So as you can read, I think I have written also here that we can quantify for every unit increase in the independent variable, what would be the increase or decrease in the dependent variable, right? So that is why we can call this type of regression as a linear regression, or we can say the variables are linearly related, right? Now, regression, when I talk about the linear regression, we can divide this into the two parts, or there are two types of linear regression. First one is the simple linear regression. Second one is the multiple linear regression. Simple linear regression meaning is what? When you are considering only two variables, right? So when you are considering two numeric variables, and out of those two, one variable will be your dependent, other variable will be your independent variable. So that is a simple linear regression. In case of multiple linear regression, you will be having the dependent variable, which will be the numeric variable, and you can have more than one independent variables. So always we are taking the one dependent variable, but independent variables can be one or more, right? So means it is depending using the one variable I want to predict my dependent variable, or using more than one independent variables I want to predict my dependent variable, right? So that way, if I'm having multiple independent variables, it is a case of multiple regression, and the variables can be of like all the independent variables can be numeric also. These can be the combination of numeric and categorical also. So this is the variety in the linear regression. I hope till here I am clear.
Yes.
Yeah. Moving to the next. Now coming to the formulation of hypothesis. So the sheet which I have provided to you related to the advertisement and sales, in the same context the hypotheses are these are the varieties, means in any form you can make your hypothesis. So firstly, advertisement is not related to sales. There is no significant relationship between advertisement and sales. There is no significant effect of advertisement on sales, and there is no significant influence of advertisement on sales, or there is no significant impact of advertisement on sales. Getting my point? All the mentioned statements are almost similar in meaning, right?
Yes.
Yes.
Yes, ma'am.
Now coming to the most important part of linear regression. So you can see there are so many assumptions, right? First assumption is variables, because I'm talking about simple linear regression. So you can see the first assumption says both the variables should be continuous in nature. Both the variables should be the numeric, either interval scale variables you need to have or ratio scales variable you need to have. Second one is there needs to be linear relationship between the two variables, right? So whatever two variables you are considering, you need to see whether the two variables are linearly related or not. If linearly related, you will proceed. If not, it is suggested don't go for the linear regression and opt for some other regression. Third one says there should be no significant outliers. I think in the books and something we are finding this much only, but we are knowing this thing that whenever we are talking about the outlier kind of thing, we need to see the outlier in the dependent variable, right? Now, next comes the residuals. I think maybe people are knowing this term, residual. If not, in the upcoming slide, I'll discuss this. So the residuals of regression should follow normal distribution. This is very important because in the regression, everything is roaming around the residuals. So assumptions are also linked with the residual term, right? So residuals should be normally distributed in case of regression. Second, next one says there should be absence of multicollinearity. Next says the values of residuals should be independent, and that you can check by this particular test. The residuals needs to show homoscedasticity, that is homogeneity of variances. Means your residual should show equal variance, right? Then lastly, there should be no influential cases which is influencing your model, right? These are the certain assumptions which you need to check in the regression, right? Moving ahead, coming to the term residual. Residual is what? As I said, we are using the regression for the forecasting purpose, right? So if we are using regression for the forecasting purpose, so it is quite obvious if I'm forecasting, suppose we are having the data of reading time and the TV watch time, right? So I said reading time will be the dependent variable, right? TV watch time will be the independent variable. So whatever the forecast I have done for the reading time for the student, right? And whatever is the actual reading time of the student. So I can make a comparison, predicted value and the actual value. So the difference which is observed by us in these two values is known as the residual, right? So if residuals or residual values are more in terms of magnitude, that means your model is not a good model, because it is indicating the difference is coming more. Means whatever you are predicting is not very close to the actual value. So if the difference is very high, that means residuals are residuals are very high. That means there is a problem with your model. Model is not an accurate model or is not a good model, right? So here you can see this is the fitted line, the solid line, and these are the data points, or these are the residuals, I must say. So you can see there is a difference. Means these all are not following exactly on the line. So this is indicating the deviation. So these terms are known as the error terms. So the black line, the fitted line, the solid line is the what I can say forecasted line, and these are the actual values. The blue one is the actual values. So we can see the difference in this. If these are very, very far from the fitted line, that means the residual value is high here. Getting my point? So this is indicating the residuals or the errors. Clear?
Yes, ma'am.
Yes.
Thank you. Now talking about the one of the assumptions of the regression, which is related to the homogeneity of variances. I think that was the second last assumption, right? So if your residuals, when you are plotting them on a scatter plot, are showing you this kind of distribution, I'm showing you where I'm talking about. My cursor is on the graph now, that is at the left side, right? So if this type of distribution of the residuals are coming using the scatter plot, you can say your data is or your residuals is homoscedastic. That means equal variance is there in the residuals. But if your residuals are showing certain kind of shape when you are plotting them on a scatter plot. So here, if you can imagine, if I'm drawing here two parallel lines, and then I'll come here and I'll go here. So you can see it is a cone type of shape, maybe you can see, right? So a shape can be anything. It can be a fan shape, it can be a cone shape. You need to understand the shapes, right? If they are showing you a certain kind of shape, that means the residuals are heteroscedastic in nature. That means homogeneity of variances is not met by the residuals. Getting my point? Shape is not good. That means it is not meeting the assumption. Is it clear?
Yes.
Now, one more way to show you this, you can see the graph. If you are finding any shape, it is heteroscedastic. If no shape you are finding, it is homoscedastic. Equal distribution to the zero value above and below is good, right? Fine. Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Now coming to that term which I want to talk to you, which is the, I think I just said, we can fit the, we can go for the modeling of the variables, right? So in mathematics, we all have studied one equation named as straight line equation. And looking at the equation I'm showing you in this slide, you can correlate with the equation which you have studied. We have studied generally y equals to mx plus c or y equals to a plus bx. This equation we have studied. That is the mathematical equation. But when we are coming in the statistics, when we are talking about the regression, one more term is added in the equation, which is known as E, right? So you can see y equals to a plus bx plus E, or maybe y equals to alpha plus beta x plus E. So y is your dependent variable, your outcome variable. This is what you are predicting. This is your predicting variable. A is the intercept or constant. P is the slope or the coefficient of the x. And x is what? It is the independent variable, predictor variable, input, explanatory, regressor variable. So many names you can find. E is the error term or the residual term, right? So this way, this equation we are generally making in the regression, in the linear regression, right? Clear?
Yes, ma'am.
Yes.
Okay, so I hope the concept of regression is clear. Shall we go now to perform regression?
Yes, please.
Yes.
Fine. So I think I need to open, yes, I need to open the file which I have provided to you. Yeah. So this data I have made using the concept of, as we all watching TVs, various apps, and we all encounters many ads, right? So purpose of ads is what? Companies want to make their consumers, maybe the present existing consumers or the prospect consumers or customers, that what is new in their product and services, what kind of features the product and services are offering, what are the new things coming, what are the offers, discounts, etc. So companies are investing huge amount in the advertisement nowadays. We all have seen or experienced this thing, right? Purpose is very simple. There is a competition. They want to make or allure customers, right? So if company is investing very highly in the advertisement, purpose is very simple, to increase the sales, right? So in this particular data, I have provided you the advertisement expenditure data along with the sales data, right? So I think it is now quite easier for you to understand which is the dependent and which is the independent variable.
Yes, ma'am.
Dependent is sales and advertisement is the
Dependent is sales.
advertisement is the independent role.
Very good. Thank you so much, ma'am. So if we have understood this thing, can anyone help me to make the hypothesis? Anyone?
Advertisement has significant influence on sales.
Sorry, advertisement?
Has significant influence on sales.
Very good. So we can say advertisement has significant influence on sales, or there is no significant impact of advertisement expenditure on sales. Sir has made alternative hypothesis. I have told you the null hypothesis. Then clear?
Yes, ma'am.
Yes.
Fine. Clear. Now, when we talk about the assumptions checking of regression, so almost all the assumptions we can check using the regression output only, right? So we will directly go in the regression and we will apply regression first, right? Go to the analyze, regression, and then linear. I hope you people have reached to the linear.
Yes, ma'am.
Okay, click here. As we know, advertisement is the independent, sales is the dependent. So we are shifting them. Done.
Ma'am, actually my internet connection was, can you please repeat the steps?
Okay. Go to the analyze, regression, and linear.
Thank you, ma'am.
Yeah. Now, advertisement I'm shifting in the independent box, sales in the dependent box. Done.
Yes.
Yes.
Now, at the below this independent box, you can find the method written is enter. So as we are in the simple linear regression, so there is no use of these methods. Only enter method will work here. Other methods are for the multiple regression, stepwise remove, backward and forward, right? So I think we will go with the by default method, which is enter. Go to the statistics now. Done.
Yes.
Click here on the descriptives. Then collinearity diagnostics. If you are making your notes, you can write collinearity diagnostics, that is multi-collinearity test, right? This is we need to apply when we are talking about the multiple linear regression. In case of simple linear regression, there is no use of this value because we are having only single independent value. When we are having multiple independent variables, in that case, we want to see whether those variables are themselves related with each other or not. So that is why there is a use of collinearity diagnostics. In case of simple linear regression, we do not need to report this, but still I'll show you what this value is coming and what you need to report, right? So that is why I have selected this. Coming down to check the residual are not auto-correlated, right? You need to check that assumption that you can check using the Dolben boxing. So select this also. Done?
Yes, ma'am.
Click on continue. Go to the plots. Predicted on X, residual on, no, residual on Y. Done?
Yes, ma'am.
Next. Continue, then you can click on continue.
Ma'am, in the Y we have to do B depend Z peg.
On Y residual, Z residual,
Z residual. Okay. And on X?
Z predicted. Then done. And then
Yes,
click
ma'am.
on the normality plot. Normal probability plot. Then click on continue. Done.
Yes.
Your skin is sorry, your screen is not visible to me. I don't know whether it's problem is from my end or yours.
Okay.
No,
What
the
about
screen is gone, ma'am. The
Not
screen is
visible.
not visible.
not visible?
It's not
Screen share
visible.
is not visible.
Just a minute. Again, I'm sharing. Maybe mistakenly I have clicked on where were we? Yeah. Done. Plots you can check. This is what I have made. If you have not done. Done.
Now done, ma'am.
Click on continue. Click on save. Done.
Yes, ma'am.
Yes.
Now select cooks. So if you can recall, one of the assumptions was there should be no influential points which can affect your model that you can check using the Cook's value. So this is I selected. Done.
Yes.
Yes.
Continue. And rest, nothing you need to do. Yes, rest is fine. Click on OK now to get the output. So shall I click on OK? Everyone has done every checking and selections.
Yes.
Okay,
Yes,
click
ma'am.
on-
Yes.
click on OK. We are getting the output now. So once you have got, please tell me so that we can proceed.
Yes.
Now you can see we are having the first table named as descriptive statistics, which is telling you the mean sales is 10.08, mean advertisement expenditure is 3.5, the standard deviation in the sales is 2.08, and in the advertisement 1.47. 30 and 30 observations we are having. As I told you, correlation becomes the precursor of the regression. So that means before giving you the results of regression, it is indicating you the correlation results also. So you can check between the sales and advertisement, the correlation value is coming as 0.862, right? And the significant value is 0.000, which is less than 0.05. So what you can say, the two variables are strongly correlated, positively strongly, because positive symbol is plus, right? And value is greater than 0.7. So we can call it as a strong positive correlation between sales and advertisement, right? Then
Yes.
you can make your notes also, because the regression is somewhat little bit, not everywhere, somewhat some explanations maybe people can find little tough. Coming to the next, variables entered, removed. So I think we have used the enter method here, which is shown here. Coming to the model summary. So in the case of model summary, R is the same which you have seen previously in the correlation table. Next comes is the R square, and after that there is the adjusted R square value, right? So you need to report R square instead of adjusted R square in case of simple linear regression. So if you are making your notes, you can write simple linear regression, report R square, multiple linear regression, report adjusted R square. Clear? Simple linear, R square, multiple linear, adjusted R square. This is you need to note down somewhere if you are not much well versed with the regression. Then
Yes.
Yes, ma'am.
yes. So now R value is coming as 0.862, which we have already interpreted. So coming to the R square. Now you can note down what R square says. I will tell you the explanation or the interpretation of both R square and adjusted R square is same. Only when to report which one, that is important, and that I already told you, right? So now you can write what R square says to us. R square explains percent variance explained by independent variable in dependent variable. Percent variance explained by independent variable in dependent variable. Meaning is that if you will look at R value, which is 0.743, we say there is the advertisement expenditure is explaining 74.3% variance in sales. Clear? Means how much change is caused by, how much percent variance change is caused by the IV
volume bottom up media.
So we can say around 74.3% changes in the sales are because of advertisement expenditure. Getting my point?
Yes.
Yes, ma'am.
Yes. Next is Darwin-Watson value in the same table, in the model summary table. So generally this should be in between 1.5 to 2. It should be less than 2 usually, right? So if it is less than 2, what we can say? We can say that the residuals are not auto-correlated. Means there is no relationship among the residuals. This is what you can interpret in the Darwin-Watson. It should be less than 2. Okay? Then?
Yes.
Coming down, yesterday I told you ANOVA is the precursor of regression. So you can find here we are getting the ANOVA table also. So in a case of regression in the ANOVA table, you need to report F value and the significant value of TF, which is 0.000, right? That means it is less than 0.05. Meaning is what? That means you can conclude here that your model is a good fit. So to check the fitness of the model, we are using here the ANOVA value, right? So we are commenting that the model is a good fit between the variables, whatever variables we are considering. Between them, model has fitted correctly or appropriately, right? Getting?
Yes, ma'am.
Yes.
Coming to the next table, which is the coefficients table. So this table can help you to build.
It was in a kind of to sound nice.
Shall I proceed? Someone is asking or talking to someone else? Okay, so talking about the coefficients table, you can see here in the coefficient table, under the unstandardized coefficients, you can find constant value is 5.804 and the advertisement coefficient value is 1.220, right? And before reporting these two values, you need to check we are having also the T statistics available here. So this T statistic along with the significant value, you need to see the role of the T value is what here or its significant value. The role of this is that it is helping you to say this thing that the both these things, that is the intercept value and the slope value, is significantly contributing to your dependent variable or not. So in our case, both the significant values are less than 0.05. That means we can say that the intercept and the slope of the advertisement both are significantly contributing to the sales. Clear?
Yes, ma'am.
And at the last, you can see in the same table, we are also getting the VIF, variance inflation factor. This is we are using for reporting the multi-collinearity. As I said, in case of simple linear regression, there is no use of this VIF. But if you are performing multiple regression, in that case, there is a role of this VIF. So you can write the what I can say threshold value. VIF value should be less than 5 for the multi-collinearity. If this value is greater than 5, that means there is a problem of multi-collinearity. Clear? I hope you people are noting down.
Yes, ma'am.
Noted? Done. So this is, I think you are not supposed to report. This is also we are not supposed to report. Come down to the PP plot. This plot is for the normality checking of the residuals, whether your residuals are normally distributed or not. So looking at the fitted line, the black line is the fitted line, and these are the values, right? You can check here. Yeah, you can check here. There should be the, means this data point should exactly follow the fitted line. That is the solid line, but we can find there is certain deviations. That means there is a problem we can see in the normality of the residuals. Clear? I hope clear, friends.
Yes, ma'am. Yes.
Yes, yes, ma'am.
Going down, looking at the scatter plot. So if you can recall, I told you scatter plot we are using for understanding the homogeneity of variance of the dependent variable. So you can check. This is the zero line, right? Looking at the zero line, you can tell me whether you are able to see any shape in these residuals. I think no shape we can find here, right?
No shape, ma'am.
Yeah.
Yes, yes, ma'am.
And also, when I talk about the zero line, you can see above the zero line and below the zero line, almost equal distribution is there of the residuals. So that way we can say homogeneity of variance or equality of variances is maintained by the residuals, right?
Yes.
Now
Yes,
come to the main file, your data file. You will able to see one column is added there. Cook's value. Visible?
Yes,
Yes.
sir.
Yes. So Cook's value is there is a formula of getting the standard value. You can see Excel file is visible.
Yes, ma'am.
So for Cook's value, you can get the standard value by 4 by n. N is what? The sample size. So here I'm writing 4 by 30, which is giving you font size is little smaller. I hope it is visible now.
Yes, sir.
0.13. So you need to see all the values which are coming here in this column should be less than 0.13. If any value is greater than 0.13, that means that particular pair is influencing your model. Clear? I think you can find this one is greater than 0.13. Remaining every value is less than 0.13. Clear? So if you are dropping the observer or the pair number 27, maybe it can little improve your results. Clear?
Can you repeat once what is Cook's value tells?
It is indicating which pair is influencing your model. So standard value I told you, you can calculate using 4 by n. And then you can compare all your Cook's value from that calculated value. Wherever the Cook's value is greater than that value, that is indication that that particular pair is influencing your model.
Even value 2 is greater than 0.1.
Which one?
Value number 2.
Yeah. So you can diagnose and then you can take a call to drop them, and you can apply regression again after dropping these 2 points, and that way you can see whether improvements is coming or not. If not coming if improvement is not coming, you can again report the previous results which are considering these 2 values, right?
Yes.
Okay. So this way it was the simple linear regression. Now I will summarize the session for the day. And then I'll take your questions if you are having any, right? So friends, I'll say today we started our journey from correlation, right? We understood the concept of correlation. I said correlation can tell you the strength and the direction of the relationship. These 2 things we can understand using the correlation. Usually correlation can be there is what I can say 3 types of correlation I have explained you. That is Karl-Pearson's coefficient of correlation, Spearman's rank correlation, and Kendall's tau, right? So Karl-Pearson's we are using in case of numeric variables. Spearman's we are using in case of ordinal variable, and the Kendall's tau we are using in case of the nominal scale variables, right? We have understood this thing that when we are measuring correlation, we are generally representing this by small r. The value of r lies between -1 to +1, right? The minus and the plus sign are important here to decide whether the relationship is positive or negative. Then we have seen that how to apply, right? We have seen the how to check the assumptions. Two assumptions primarily we need to check. Mostly we need to check related to the normality and the outlier, which we will check in case of dependent variable, right? I told you portion do not make any differentiation between the dependent and independent variable. It is only considering the two variables to give you the portion value. But we, being a researcher, can understand this thing, which variable is the dependent and which variable is the independent, right? Further, we have talked about the regression, and I told you we can do many things using the regression. I think one thing I forgot to tell you. One of you have asked me the modeling or equation. Someone has told me, right?
Yes, ma'am. I
I
had asked.
forgot to tell you that. I will tell you this thing, and then we will conclude the regression. Font size is visible, I hope.
Yes, ma'am.
In our case, what were the results? 5.804 plus 1.22 multiplied by. Yeah, this is the equation, right? So if you are having advertisement expenditure value, you can replace it here, and you can solve this equation. That will be your predicted value of the sales. Then whenever you are having the actual sales value, suppose you are predicting the sales for the next month. So next month sales, once the actual sales value coming to you, you can compare the actual sales with the forecasted sales, I can say. And then you can see the difference is coming or not. If difference is coming, that means you can say if residuals is very high, you can say there is a problem with the model, right? So you need to do this kind of thing. It is clear, I hope.
Yes.
Yes, yes.
Yes. So this way, this is the model building in the case of regression. So now I will come to the summarization part. I'll say when I talk about regression, I said regression is doing so many things for us. First thing, it is helping us to understand the causation, that is cause and effect relationship between the variables. I said it can help you to understand the algebraic relationship between the variables. That means you can quantify the relationship between the variables, or you can find the magnitude of the relationship between the variables when we talk about regression. Also, this test will help you to understand the modeling between the variables, and we can do the prediction or forecasting of the dependent variable using the independent variable or independent variables, right? Then we move further. I said regression considers independent and dependent variable, which we cannot consider in case of correlation, right? Then we have seen the linear regression. So I talked about the two linear regressions, simple linear and multiple linear. In the simple linear regression, we will be having the one dependent and one independent variable, and we will be having the two numeric variables. These two will be your numeric variables. In case of simple linear regression, we will be having one dependent variable and more than one independent variables, right? So process of performing the multiple linear regression is also same. Nothing you need to do. The same way, you need to shift only your single dependent variable into the dependent box, and all the independent variable you will shift in the dependent box. And all the processes, all the check boxes and everything which we have done, same you will do, and output will be generated for you. So in the coefficient, we will be having the multiple coefficients value according to the number of independent variables we are taking. So that way you can make your hypothesis, right? Then we talked about the assumptions, which are very imperative in case of regression, because most of the assumptions are dealing or talking about the residual or related to the residuals, right? So initially we have seen we need to have two numeric variables, we need to have the linear relationship between the variables. Then we have seen there should be no outliers in the dependent variable. Then after that, the residual assumption started. So I said residual should not be auto-correlated, means one residual should not be related with the other residual. So that thing you need to check. You need to check the residual should be normally distributed. You need to check that the residuals should follow the homogeneity of variances, and you have to check there should be no influential value in your data. So that way, these are the assumptions which we have discussed and checked also, right? After performing the regression, I think I explained you the many things. The important thing which you need to report in case of regression is R value, R square value, ANOVA value you will report along with the ANOVA, and that means the F and significant value you will report. You will report dozen works in value. And in case of multiple regression, you also need to report VIF. But in case of independent, in case of simple linear regression, you do not need to report VIF value, right? After that, you will come to the coefficient table, and then you need to report the T and the significant value of the T for the coefficients, that is the intercept value and all the slopes, if you are taking more than one independent value, right? And then if you are finding all the T significant values are less than 0.05 or from your level of significance, in that case, you will declare that the independent variables are significantly contributing to the dependent variable, and you will then make your model like this, right? So friends, this is about the regression and correlation from my side. Now the platform is open for questions and answers. If you are having any, you please ask.
Hello, ma'am.
Yeah.
So, ma'am, like I was not able to follow when it comes to the graph in the correlation. So,
Sorry, not getting you, sir.
yeah. So, like, ma'am, I was not able to follow when it comes to the graphs of the correlation. Like, while. So, can you please, like, once more guide?
Can you share your screen? I'll guide you. You need to do, I think that way you will maybe grasp more. If you can share your screen.
Okay, okay, ma'am. Is my screen visible, ma'am?
Yes.
Yeah. So, is the correlation data visible?
Go to the graphs.
Yes, ma'am.
Chart builder.
Yes, ma'am.
Okay.
Define variable properties.
Okay. No, I said okay.
Okay, okay. Sorry.
Right. Now
Yes.
come down in the chart section, select these scatter plots.
Yes, ma'am.
Yes. Select it. First one you need to select. Double click it,
Yes.
or yeah, double click or drag or drop it in the preview area, upper side.
Here, ma'am.
Yeah. Drop it. Drag and drop or double click also you can do, sir.
Yes, ma'am.
Now shift. Reading time we have taken as a dependent, and TV one is we have taken as an independent. So dependent variable we are keeping on a y-axis. Drop it. Drop it.
Yes, ma'am.
Then click on OK. Go to the output viewer.
Yes, ma'am. Is this the one?
Can you, yeah. Now double click on the chart area.
Where is the chart area, ma'am?
So chart area means where you have seen the, where you are able to see the chart. Double click on that.
Okay.
Double click.
Yes, ma'am.
Yes.
Is it visible,
the-
ma'am?
At the right side, you can see there are certain icons available. Right side, in the ribbon, right side. Yes. The fifth one.
This one, ma'am.
Yes, this one. That's all.
Okay. Okay. So this. Yeah. Sorry, ma'am.
Close this. Close that properties dialog box. Yes.
Okay. Okay. So this one up to this one, right?
I think chart editor is open. You can close the chart editor and then you can see the output in in the output window also. Above your scatter plot, you'll be able to see the fitted line.
Where in the chart editor, ma'am?
I think presently you are on a chart editor only. You can see the heading of your that graph on which you are. It is chart editor only.
Yes, ma'am. Yes, ma'am. So do I need to do anything more or?
You can close it. Nothing you need to do.
Okay. 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 Thank you so much. Thanks.
Done.
Yes, ma'am. Thank you so much.
Thank you. Okay. Any other query? No query?
No, ma'am.
Okay. Thank you, everyone. So on Monday,
Ma'am.
we'll be meeting for the, yes, you have any questions, sir? Vedanta, sir, you have any query?
Ma'am, it is not query, but I want to know something about you have classified as per the values of R in a slide, but you did not share about the negative values. And the classification have done as per positive value only, low correlation, moderate, high correlation. But you did not share about the negative values.
I'm not getting what exactly you are asking me.
It's okay then, ma'am.
But question is not clear to me, so how I can answer? Anyone who can understand what he is asking?
No, I want to ask you. You point out a slide of money means values of R classified the correlation high, low, moderate with only taking only the positive values.
No, I think in case of correlation, we got minus 0.61 when we applied on reading time and the TV time.
No. Before that,
Means I'm not getting what you're asking. Anyone who can help me to understand the question of sir?
you shared a slide.
Hmm.
Uh,
Do I need to show you again?
yeah, you show. Yes, you can show.
Just a minute. I come to the slide which you are asking me to show. It is related to the regression correlation, right? This one? I hope it is visible.
Yes, ma'am.
Yes.
This one.
Yes.
So here you show 0.3 to 0.5 is a moderate correlation. But why you are not showing the minus 0.3 to minus?
It will be a difference of minus. Whatever is the magnitude you are getting, you need to always look to the minus or to the symbol. If it is positive, we will call it as a positive correlation. If it is a negative, we will call it as a negative. So if it value is minus 0.3 or maybe minus 0.32, so you will call it as a moderate correlation between the two variables, negative moderate. So all these values are only in terms of magnitude. Symbol, according to the symbol, you can call it as a positive and the negative correlation. Getting my point?
Yes, yes, ma'am.
Yeah.
Then R greater than 0.9 you showing as a multicollinearity. If we get R is equal exactly 1,
that is perfect correlation.
yes,
Madam,
perfect
so
positive correlation.
Sorry.
A perfect positive correlation
go
if
right,
you get R is equal exactly equal 1.
Yeah, perfect
Yeah.
positive. In case of minus one, it is perfect negative.
Master
Yeah.
And that means two variables are
Yeah,
almost identical. But not almost, the two variables are identical, same.
Sure. Okay, okay, ma'am.
सबको ব্যায়াম ও এটু করিল দে এরকম করা নাই
Thank you, ma'am.
রিজাল্ট কেমনে পাস করে
Thank you so much, sir. So, any other query?
ফোন করি আছে ও পছন্দ করছে
So we don't have class tomorrow. We have class
Tomorrow,
on
I
Monday.
think Sunday, we are not having any class, sir. Now we are meeting on Monday, and I'll go for the application-based discussion of all the tests which we have in these 6 days, right?
Okay, okay, got it.
Fine. So thank you, everyone. If no more questions, we can close the meeting. We can call off the meeting for the day. We are meeting on Monday now. There will be no class tomorrow, right? Fine.
Okay. Thank you so much.
Okay. Thank you, everyone.
Okay.
Yeah. So, Yoga sir, we are done for the day.
Thank you very much, madam.
Thank you so much, sir. Yogi sir, are you there? Yoga sir, we are done. We can close the meeting. I hope you are hearing me, sir. Are you in the meeting? Yoga sir, are you there? Well, we are done. Thank you so much, sir.